something. They learned that high-speed buses can be sniffed. They are putting the encryption device in the CPU, or at last we think it's in the CPU, because everything else could be sniffed. They know that keys can be snuffed out with, if you have really expensive hardware, you could maybe even sniff inside the CPU, and you could derive the secret key used for booting. And so they choose an approach. They give each Xbox a different key for booting. So each Xbox user has a completely other boot image because it's encrypted with another key. And IBM offers these eFuses. Fuses are in the chip. They can be read in the chip and they can be burned. But normal fuses can be burned while the production with a laser device or something. And these eFuses can be burned after production with a CPU instruction or something. So they are able to give each Xbox CPU a different key, which is very important because if somebody sniffs out a key of one Xbox, they can't produce a flash ROM which works on other Xboxes because each Xbox has a different key. That's a very strong, very strong security at the first look. IBM normally uses these eFuses for parameters which differ from chip to chip, maybe due to production issues. So for example, the exact voltage a chip must be operating could be different from chip to chip, maybe some millivolts more or less or something. So they measured while production and set the eFuses accordingly. But it could be perfectly used for having per CPU keys, but we don't know. It's still unconfirmed if the eFuses in the CPU are actually used for security or not. There's a paper from IBM about the CPU and it doesn't mention security at all, but maybe they just hide it or it's just not implemented there, but for example in the Northbridge or something. Additional security, yes, non-executable pages is not really new, but I think it's new to consoles. In fact, the official linker, it was told to me from Microsoft, doesn't allow writable and executable segments. So they either have to be writable or executable, but not both. And if you do this and have your stacks non-executable, you can't do the traditional buffer overflows anymore. But as we all know, there are ways to work around this, but they are very hard if you don't know the exact code on the system. And the code is, of course, encrypted, and that makes it much more difficult to do a buffer overrun. Of course, if you have ideal software, you don't have any buffer overruns. But if there are any buffer overruns, they aren't as easy to exploit as previously. So yeah, we have to see if this works out, but they tried it at last. Possible attacks, there are no real attacks until now, but recently somebody dumped the kiosk disk, and there are Xboxes which, it's a kind of demo disk. So they offer information about the Xbox and so on, and have some game demos on it, and somebody dumped that disk, and well, each binary on the disk, which is executable, is of course signed, so you can't change anything with the private key, which isn't known, and the Xbox can check if there's nothing changed. But there's a bit field which says the allowed source media. For example, a normal game executable, of course, has said that it can be only run from an original Xbox game disk. But this kiosk disk, the binaries on that kiosk disk were signed as run from everywhere. So you can put them on a normal CD, you can burn them, and they run. That alone isn't really a security threat, but maybe the games are exploitable or something. Then it would become a security threat because you can just burn them to CD and then execute them. Data files are still not always signed. So this could be a way to attack one of the games, and if we find an exploit in one of these games, we would have a way, to run maybe our own code or something. There's still a new type of processor now, because the GPU does support shaders, and shaders are mainly for graphic processing, of course, but they are so powerful in the meantime now that they can be almost used as general purpose CPUs. Well, they can only, or are optimized for float numbers and so on, but they are code, and especially on the Xbox, they can read and write to physical memory. This is done for loading geometry data and so on. And they have a special instruction called a mem export, and they can access the physical memory. And now if some games, they have their shaders in non-signed areas, so we can change them and burn them on CD. And maybe it's possible to make a shader which can then attack the physical memory, write our code there and so on. But as I said before, all code is encrypted in physical memory. But obviously the data is not encrypted in physical memory because, for example, the GPU must access geometry data and textures and so on, and they can't be encrypted. So we could change data, we could change stack frames and so on, modify return addresses, and it could be pretty much fun messing around with shaders and their features to access the memory. This is one possible attack. It's a very recent discovery of this kiosk disk and the shaders which are there. So we have to see if this works out. Currently there is no real attack, as I said, but maybe, time will tell, and it's just a month since the release. I hope this changes. So, the current state is so far you can't run Linux, but the good thing is you can't run any pirate games. And that is good for Microsoft. And if you want to keep track with the information of the, there's a project called 360. The website is marked there, and Michael just want to show you something. And well, so maybe there are people who never saw an 360 before, so this is one of them. And this is, well, the upper one here is the mainboard of the 360, and the lower one is some hardware we have attached, trying to hack it or sniff it, but provide us a lot of information, but no real attack yet, but I hope this will change. That's, I think, all which can be told about the Xbox now. Just look at that page. It's all new discoveries will be posted there, and thank you very much for your time.